So today we are going to solve quadratics by factoring, and there are 3 steps to this process. The first step is to make your equation set equal to 0. Then the second would be to factor using all the methods that we learned in the previous lesson. And then the third is to take each factor, set it equal to 0, and then solve the resulting mini equations. One thing that I'd like you to keep in mind as you're solving these is that when you solve quadratics, the answers that you get are called solutions, zeros, roots, or x-intercepts. All of them mean the same thing. So let's look at some equations. Our first equation is 8a squared equals 6a. So our first step is to make that be set equal to 0. Once we get it set equal to 0, we can take a look at what type of factoring would apply. And in this case, the only thing that we can do is factor out a GCF. Our GCF for this equation would be 2a. So if we factor out that 2a, then we get 4a minus 3 left over. And so then again, that equals 0 still. Now there's nothing left to do as far as factoring here, so then our last step would be to take each factor and set it equal to 0. And we have 2 factors. One of them is 2a, and the other one is 4a minus 3. So if we take both of those and we set them equal to 0, then we have 2 mini equations that result from that. We solve each one, and we'll get 2 solutions. So your first solution would be a equals 0, and then your second solution would be a equals 3/4. Our second equation is 3x squared minus 8x equals 11. So again, the first thing to do is to get it set equal to 0. Then once we have it set equal to 0, we determine what type of factoring would apply. This is a trinomial, so we know that we're going to get 2 parentheses. Now, we have a 3 in front of the x squared. If we can factor out that 3 as a GCF, then this will become a simple factoring problem, but in this case we can't. Therefore, we have to turn this into a grouping problem. So we take the 3 and the negative 11, and we multiply that to get our negative 33. Then we're looking for 2 numbers that will multiply to give us a negative 33, and we'll add together to give us that negative 8x in the middle. So we can use positive 3 times negative 11 to get negative 33, and then that will also combine to give us a negative 8x. Now remember that that 3x squared doesn't change. Our negative 8x will become a positive 3x and a negative 11x, and then the negative 11 on the end still stays the same along with the equals 0. Now that we have 4 terms, this is a grouping problem. So we will group the first 2 terms and we'll group the last 2 terms. We take a look at our first group and we determine what we can factor out of it, which is just going to be simply a 3x. So when we factor out the 3x, we get x plus 1 left over. Out of the second group, we see that we can factor out an 11, but more specifically, we need to factor out a negative 11 because of that negative in the front of that group. When we factor out that negative 11, again, we are left with x plus 1. Now we're able to factor out that parentheses that they have in common. So when we factor out the x plus 1, that becomes our first factor, and then our second factor becomes what we pulled out of each group. So we have the 3x that we pulled out of the first group, and we have the negative 11 that we pulled out of the second group, and then that entire thing is set equal to 0. Now the equation is factored, and we simply have to take each factor, set it equal to 0, and then solve the equations. And there we have our 2 solutions, x equals negative 1 and x equals 11 over 3. Our third problem is going to be 6x squared plus 3x minus 108 equals 0. Now when we first look at this, we think that that's going to be horrible. Those are really big numbers. But what we notice is that all of those terms in that equation can be divided by a number, in this case 3. So we're going to divide every term in that equation by 3. And we get 2x squared plus x minus 36 equals 0, which now means we have much more manageable numbers. Now unfortunately, we still have a number in front of x squared, which means we're going to have to multiply and turn it into a grouping problem. So we take the 2 in the front and the 36 in the back, and we will multiply those together to get 72. Now we're looking for two terms that are going to multiply to give us negative 72 and will add together to give us a positive 1x. So if we look at all the combinations we have that will multiply to give us 72, remember that we're looking for two terms with opposite signs because we have a negative 72. So we're looking for two numbers that will subtract to give us a positive 1. And in this case, we would want to use the 8 and the 9. But we also have to think about which one is going to be positive and which one is going to be negative. Since we want them to combine to be a positive 1x, we need the larger of the two numbers to be positive. So we're going to have a negative 8 and a positive 9. Now when we take that over in our problem and we split that x into negative 8 and positive 9, we have the 2x squared that stays the same. The positive x is broken down into a positive 9x and a negative 8x. And remember, it doesn't really matter which order you put those two in. Your answer should come out to be the same either way. We bring down the negative 36 and the equal 0. Now we have four terms, therefore we can do this problem using grouping. So we create our two groups with the first two terms and the last two terms. If we look at our first group, we're looking for what we can factor out of both of those terms, and in this case the only thing we can factor out of both of those is an x. So we factor out the x and we're left with 2x plus 9. When we look at the second group, we notice that it starts with a negative 8x, so we know we need to pull out a negative, and 8 and 36 can both be divided by 4. So we're going to pull out a negative 4, and we have 2x plus 9 left over again. And we still have our equal 0. Now remember that we're going to factor out the common parentheses. So if we factor out that 2x plus 9 in the front, that becomes our first factor, and our second factor will be the two things that we pulled out of each group. So we have x from the first group, and we have minus 4 from the second group, equals 0. Now we take each one of those factors, we'll set them equal to 0, and solve our equations. So our first factor is 2x plus 9 equals 0, and when we solve that equation, we get that x equals negative 9 over 2. Our second factor is x minus 4 equals 0, and when we solve that, we get x equals 4, and those are our two solutions. For our last problem, we have 4x squared minus 36x equals negative 81. Again, first thing we need to do is to make sure that it's set equal to 0. So when we move that 81 over, everything will stay the same except that 81 will now become positive 81, and it will equal 0. Now if we look at this, I notice that both that first term and the last term are perfect squares. However, we're not missing the middle term like we were yesterday with the difference of squares, but we can do something very similar. My first term is 4x squared, so that is 2x times 2x. My second term, or my last term, is 81, so we can do that as 9 times 9. Now notice though that we didn't make them opposite signs like we did yesterday with the difference of squares. We made them the same sign, and this is why. If we take the first and last terms and we multiply them together, we get negative 18x. If we take the middle two terms and we multiply them together, we also get negative 18x, which together gives us a negative 36x, which is what we have in the middle. So that's just one of those patterns that you will learn to recognize. So if we multiply those two factors together, it would in fact FOIL out to give us what we had originally started with. Now we do have two factors. However, they happen to be the exact same factors. So we really don't have to write the same factor twice equals 0. We can just take that one factor, set it equal to 0, and we get that x equals 9 over 2. If I were to go ahead and take that second factor and set it equal to 0, I would get the exact same solution. So if I were to get the same solution twice, then that's what we call a double root. We have the same factor twice, which would give us the same solution twice. Therefore, it's called a double root. So as you can see, solving quadratics by factoring is really the same thing that we did in the previous lesson. We're going to factor all the same ways, but then when you're done, you're going to take each factor that you got, set it equal to 0 and solve, and then you have your solutions. So, happy homeworking!